So these are given parameters. Initial mass, mass after rocket operation, that means the dry mass. MF means dry mass. M naught is wet mass. Again, pilot and the structural mass, MS is given. Duration is given. ISP is given. So what we are required, and the acceleration of the rocket is limited to 35 G naught. So this is very high acceleration. That means 35 times of the acceleration of the Earth's gravity. So these parameters are given. So it is required to find the mass of consumed propellant, the total mass of consumed propellant obtained for 17 kilogram. Mass ratio of the vehicle, or the mass ratio of the rocket, is 0.65. The mass ratio of structure is obtained 0.222, and the propellant mass fraction of the propulsive system is obtained as 0.778. So now, once we have found these results, we can find the effective exhaust velocity, which is ISP times G naught, and then the propellant mass flow rate, MEP, which is the mass flow rate. Simply we call mass flow rate, but it is a propellant mass rate, flow rate. Why? Because the consumable mass in the whole rocket system is the propellant. Others are constant. Okay, so that whatever the change in mass happen, it is there because of the amount of propellant consumed. So that M dot means MP in our case. So this MP is equal to MP dot is equal to MP divided by T. So which gives you 23.3 kilogram per second. Then we can find thrust now, because we have effective exhaust velocity, we have propellant mass flow rate, so that we can find the thrust in optimum condition. So this is thrust of this vehicle, and the total impulse also found from thrust times, it is just thrust times change in time. And then the impulse to weight ratio, which is IT over W, can be obtained from this combination. So weight naught means weight of fuel, weight of final weight plus propellant weight minus structure weight. This W naught is the final weight plus weight of fuel minus WS. But this weight of final weight plus weight of fuel means it is total weight, initial weight, or weight naught. Okay, so 2000 minus structure weight is given 110, so we can get this thing. 187 second is the impulse to weight ratio. Okay, now we are going to calculate the acceleration of this vehicle. The acceleration of this vehicle is equals to the thrust divided by mass of propellant. Once we know mass of propellant, then thrust is already calculated here. Okay, so by dividing that, we can find 422.58 meter per second square is acceleration. But we expected the this means what? This value is equal to 43.08 times the gravitational acceleration. If you multiply gravitational acceleration by 43.08, it will give you this value. So this value represents higher than the expected acceleration of the vehicle, so that the vehicle can at the Earth's surface, it exceeds the stated 35 G's limit, so that our vehicle is safe at this. Why? Because it is operating higher than expected value, so the vehicle is still safe. So this is fair design. The design which we followed is fair. If this value is less than this value is less than 35, then it is not fair. But our calculation gives us 43.08 G naught, which is greater than 35 G naught. So our design can be in safe region. Maybe ገብቷችኋል እዚህ አካባቢ እያልኩ ያለሁት? Hello. Hello.
አቤት ዶክተር።
ይሄ አባባሌ ግልጽ ነው እዚህ ጋር እያልኩ ያለሁት? እዚህ ጋር እያልኩ ያለሁት ይሄ ምን ማለት ነው? እዚህ ጋር ጥያቄው ምን ይላል ተመልከቱ። Assume constant thrust and neglect the short startup and stop transients as well as the force of gravity, which is being balanced by the lift of aerodynamic wing. Okay, before that, sensitive electronic equipments in the payload would limit the maximum acceleration to 35 G knots. Look, the maximum acceleration is 35 G naught. Is this exceed during the flight? The question says, is this exceed during the flight? Yes, it exceeds. How it comes? Find the flight acceleration. Acceleration is equal to F over mp. So F is the thrust, 54,936. Mass of propellant is 130. So it gives you 422.58 meter per second square. This is maximum acceleration of the vehicle. This acceleration, if you change this acceleration into G, okay, means acceleration is equals to, if you divide this for 9.81, then it gives you 43.08. Divide this value, acceleration to gravity. Then you can get 43.08. So this is above the prescribed value. So does this limit is okay for our vehicle, for the sophisticated equipment inside the rocket? Is it fair?
No.
Is it fair?
No.
It is not fair because our instruments are designed to accommodate only 35 G naught. But what we have designed is 43 G naught. It is beyond the design limit, so that it have tendency to destroy or to break or to cause some damage to the sophisticated instruments inside the rocket. So we have to change this design. This design needs to be changed. አሁን ተረዳችሁ?
ከቅድሙ ክሊር ነው።
ስለዚህ አንደኛ ዲዛይኑ ፌር ነው ስንል አይኤስፒ በማየት ፌር ነው ብለናል። አንድ ጥሩ አይኤስፒ ያለው ኬሚካል ሮኬት 240 ሰከንድ ነው አይኤስፒ። ይሄ አይኤስፒ ደግሞ 187 ነው። የአይኤስፒ ቨርሰስ 187 ነው። But one determining or limiting factor is the G load. So the G load which we are designing is 43, but the limiting G load is 35 G naught, so that this design should be summarized, re-evaluated again in order to make it less than this, less than 35 G naught. If it is less than, then our equipment is safe. So this is the meaning. Okay, so the parameters which we have discussed and their units, SI unit, I will just go through only SI unit. Thrust is in Newton. Propellant flow is kilogram per second. Okay, mixture ratio is it can be varied. specific impulse is Newton second per kilogram. Exhaust velocity C is meter per second. Pressure is Newton per meter square, you know. Area ratio is unitless. Okay, heat transfer rate is joule per second meter square. Mass ratio is still unitless, mass divided by mass. Velocity is, you know, meter per second. So these are just standard units. You are familiar with this. So this is all about for today. If you have any question, you can ask. Hello?
ያው እስኪ ደግሞ እናነበዋለን አንብበን ያው እንጠይቃለን ዶክተር።
And so in the next we will start with some chemical formulations and the thermodynamic of nozzle thermodynamics ለማየት እንሞክራለን በሚቀጥለው, because a number of thermodynamic processes are take place inside the combustion chamber, so that we have to discuss that part in the next class. So whenever you are comfortable, please call me and tell me to work with or to continue our class, because your time is going very fast. Okay? ስለዚህ ንገሩኝ፣ በማንኛውም ሰዓት ንገሩኝና በተፈለገው መልክ ክላሳችን ማፍጠን መቻል አለብን። ኦኬ ሶ ለዛሬው በዚህ እናብቃለን። መልካም ቀን ይሁንላችሁ። Okay, so if any question, just ask me, please. ከሌለሽ ቻው፣ መልካም ቀን።